Hi, welcome to Mega Traffic Sim. In our last tutorial, I showed you how to make the traffic network on Google Map, and we created our first simulation on the Agnew Avenue eastbound traffic on Agnew Avenue East start from Young Street and a Banff Road. In this tutorial, I'm going to show you how to add the westbound traffic on the Eglinton Avenue to the simulation. The westbound traffic on Eglinton Avenue East start from Banff to Young Street. What we are going to do is we can keep using the road and intersection files we created last time, but we are going to add a new road to the road network. Now, this is the data template we worked on last time. It has road, intersection, and network file we need for the simulation. After the last tutorial, I spent some time worked on the name of the road and intersections to make them easy to remember and understand. So you can see now the real name is Eglinton Avenue East between Young and Dunfield, Eglinton Avenue East between Dunfield and Redpath. The same name now is eastbound Eglinton Avenue E between Young and Dunfield. So far, so forth. So the names are more understandable. These are the roads. The name of the roads we will be used for our westbound simulation. So it's actually Eglinton Avenue East between Banff and Foreman. So the corresponding eastbound road is this one, and this is our second road segment. Is Eglinton Avenue East between Foreman and Mount Pleasant. The corresponding eastbound road is this one. The third road segment, the fourth and fifth road segments. And let's keep our name convention here. I'm going to call this road segment as westbound the road name. Now we have the real name and the sim name for the westbound simulation. I also spent some time to format the numbers of the road length. I rounded them, so the length is now 239,000, sorry. So it's actually 239 meters, 225 meters, 219 meters. Speed limit is this. We keep using them. Now we can just reuse the length and the speed limit and lane change allowed indicators. This one, this one, and these settings will be the same. Paste it, and we're going to extend our simulation later, so I'm going to leave a gap in the road ID. I'm going to use the road ID for westbound start from 101 and keep going. The road IDs the value used for road ID has to go up by 1, so this one must be 102, so it must be 103, 104, 105, The road segment for westbound traffic simulation is ready. Save this file. We can keep using all the intersections because eastbound and westbound and the later simulation for north and southbound, they share the traffic light. So we are going to keep using the intersections here. And for the network, these are the traffic network we used for eastbound simulation. Now, for the westbound simulation, we have 5 road segments and they share the intersections with eastbound traffic. So the beginning intersections will be like the last, this one, 6. So for westbound, the first intersection is 6. It's the intersection Banff and Eglinton. This one. And the second intersection is the Foreman Avenue. And the third one should be Mount Pleasant. Here. First intersection is 6, intersection 6, and the road segment is 101 between Banff and Foreman. Second one is 102, 103, 104, 105. Network 5 here, 101, and end intersection is 5. The second road segment, the beginning intersection is 5. The road segment is 102. The end intersection is 4. And the third road segment beginning intersection is 4. This way we connect all the road segments. It's 103 and 3. Here 3, 102, 104, 2, 2, 105, 1. Okay, so these are all the road segments we need for the westbound simulation, and they are connected by using the same intersection for the end intersection of the leading road segment and the beginning intersection of the following road segment. And the road unit index has to be 1, 2, 3, 4, 5. And the road ID, this is the westbound, so we need a new road. We're going to use 2, 2, 2, 2, 2. And for the turning management, we're going to use this old values, which means no vehicle turns at these intersections. 0. Paste. And the direction will be west. You can only use east, west, north, and south for the direction. And the lane number, let's say 3. And the frequency of new vehicles, let's say 4. So a new vehicle will be created every 4 seconds. So let's say that the eastbound traffic is heavier and the westbound traffic is ladder here, and this is for advanced synchronized signal simulation. Let's put 0 here. Okay, now we can save it. Okay, now the westbound traffic network is ready. We use the intersections and our new road segment here. So we save the file. Now, what we are going to do is we're going to save our network and road file to the in the CSV format so the simulator can read them. Here we are going to save us CSV, and our traffic network file is this one. We save it. Yes. Okay. Yes. And the road file, we're going to save it. Save us. Road. Save it. Yes. 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 Okay, now we have to close the Excel to release the log on the files. We don't want to save the files again. Okay. Let's take a look at our new road and traffic network file. Open with Notepad. Oh. Empty lines are not allowed. Delete it. File looks good. We save it. And the network file. It looks good. Okay. Now we are ready to go. Before we kick off the simulation, we have to let the simulator know we have new road and traffic network files. So we have to modify the MTS config file to let the simulator got the new information. Double click it, open it in the text editor. The new road file is actually road.csv. So we are going to change the road file to road CSV, and the traffic network file is traffic network.csv. So here we are going to change it to traffic network.csv. Okay, save it. We are ready to go. Okay, now we have all the data files ready. You can run the simulation. Double click MTS. Okay, it's done. We got our simulation result. Double click it. This is the simulation result. Let's make a filter here and freeze the first row. See? The road column, we now have road 1 and 2. What do we have on road 2? We have lane 0, 1, 2, 3 lanes. We have road 101, 102, 103, 104, 105. And for road 101, its end intersection is 5. Its big intersection is 6, and we always report the end intersection of the road. And when the simulation begins, the signal light was green and timing was 1 second. And this is the vehicle ID. ID is 16, and this vehicle is the first one on this road segment at this time spot. So it doesn't have a leading vehicle. The leading vehicle here is 0, 1, and the vehicle velocity is 1 714 centimeters per second, slightly faster than 60 kilometers per hour, and the location is 1667 centimeters. So it's about 16. It's about 16 meters away from its beginning. And the vehicle index on this road segment is 1, which means it's the first vehicle on this road segment. The total vehicle number on this road segment is 1. Scroll down. Okay, so let's take a look at this record. So which means at this time spot, on road 2, lane 0, road 101, timing is 5 seconds, traffic light is still green on the intersection 5. The simulation, the green light has lasted 11 seconds. See here, that's the 11 seconds of simulation. It's 11 seconds, and for this record, it's about vehicle 34. And another vehicle with ID of 16 is in front of it. And this vehicle speed is this, the location is this, and the vehicle index is 2, which means this vehicle 34 is the second one on the road segment. And yeah, the total number of vehicles is 2 on this road segment. Yeah, so here this means there are 3 vehicles on this road segment, and this vehicle is the second one. There were lane change happen during the simulation. Lane change. And yeah, okay, let's take a look at a specific vehicle. Okay, let's take a look at the vehicle 16. The vehicle 16 starts on 8001 and at 80153, so it took the vehicle 1 minute and 53 seconds to finish the whole road. What happened during the simulation? Oh, this vehicle didn't change lane during the simulation. It's okay. Let's focus on the movement record of this vehicle. Blanks. Okay, let's take a look. So let's select time and velocity and make a line chart on it. So this means during the simulation, this vehicle speed, this velocity speed changed over time. Apparently, it hit the right traffic light on this time period road. Let's take a look. It's about 8:00:55. Yeah, so it's on the road 103 and intersection 3 has the right light. You see the vehicle? It's green light, yellow light. So the velocity of it slows down. It stops here, the traffic light. Then the traffic light turns green and it speeds up. Keep going. Yeah, that's how you understand the velocity and the traffic light. Let's take a look at the location of the vehicle. We select timestamp and the location. We make a line chart here. So you can see the vehicle finish the first road at this time and it didn't stop, and right after it finished the first road segment, it enters the second road segment. It keeps going, and you can see the maximum value of the location on these 2 road segments are pretty much the same, which means the lengths of the road segment are pretty much the same. And apparently the third road segment is shorter, and the location hasn't changed over this time period, which means it stopped there for a while. Then it start to move, enter the next road segment, again another road segment, and you can see these two road segment and this one, these three road segment are shorter than the first two road segment, which we have the actual length of the first two road segment was around 300, and these three road segment length was around 200. We can see 200, 300. Okay, now let's do some other analysis here. We want to see on a specific time how many vehicles are on the road. So let's see how the traffic looks like. Let's remove the filter on vehicle column. Select all the vehicles, and let's find some big numbers of the vehicle numbers. We didn't give a high frequency for the vehicle generation, so the number of vehicles on the road segment are pretty small. Okay, let's pick up this one. It's this record. Okay, so it's on 8 o'clock 37 seconds on road 2, road segment 102, and intersection 4. Traffic light is green. Okay, so let's filter the road on 102. And set the time on 37 seconds. Okay, so these are all the records on this time spot of road 2 on this road segment for each of the lanes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 records, which means at this point we have 9 vehicles on this road segment, and they are running on 3 lanes. Let's copy everything to a new working sheet here. Copy, paste, and let's see how the vehicles, where they are on this road segment. I'm going to copy the lane column and paste it here. I'm going to use the location as X value and the lane as Y value. Insert a scatter chart. Okay, now you can see this is lane 0. We have 3 vehicles and their locations are here 5,000, here 15,000, and something between 300,000 and 350,000. This is on lane 0, on lane 1, and lane 2. See if we can make this more readable. Okay, so on link 2 we have three vehicles. Their locations are 24898, this one, and 12967, this one, and 6622, this one. And on link 1, these three vehicles, their locations are this. And on link 0, three vehicles, their locations are like this. Okay. Later, we will be using more advanced data mining and analysis tools like SQL Server analysis service to do more advanced data analysis. Okay, so stay with me. Bye.